Good morning, students. Our chapter number 6, Physical Change and Chemical Change is going on. In the first two periods, we learn about physical change and its examples, chemical change and its examples, which things will happen in a chemical change. Today, we will see the remaining part of this chapter. Students, in this chapter, we learn 8 activities. From that, up to 6.5, these activities are related with the physical change, and 6.6, 6.7, and 6.8, these three activities are related with the chemical change. We already saw that activities. Now see the next point of this chapter. Now when we saw this all the examples of chemical change, you saw that burning of magnesium ribbon is a chemical change. We already learned that burning of magnesium ribbon, when magnesium ribbon will be burned, it forms when magnesium will be burned, it forms magnesium oxide. It forms a magnesium oxide. Then burning of coal, wood, or leaves is also a chemical change. In fact, burning of any substance is a chemical change. Burning is always accompanied by production of heat. Here, burning of magnesium ribbon is a chemical change, and burning of coal, wood, and leaves are also called as a chemical change. In fact, a burning of burning of any substance is called as a chemical change, because the substance will be changed into the another substance. Like suppose coal, wood material, then leaves material. When it burns, it converts into the ash. Leaves converts into the ash. New substance will be formed. That's why it is called as a chemical change. Each and every substance, any substance will be burned, that time it is called as a chemical change. Now see the next point. Explosion of a firework. Explosion of a firework is a chemical change. You know that such an explosion produces heat, light, and sound, and unpleasant gases that pollute the atmosphere. That is why you are advised not to play with fireworks. Now, explosion of fireworks. We are aware about that explosion of fireworks. In that, which things will be produced about that we are aware. Which things like heat energy, light energy, and sound energy will be produced, and unpleasant gases will be produced, and that pollute the atmosphere. And that's why it is called as a chemical change, because here new substances will be formed, like unpleasant gases, heat and light energy, sound energy will be produced. That's why it is called as a chemical change, and pollute it pollute the atmosphere. That's why our government has advised to not play the fireworks. Now, when food gets spoiled, it produces bad smell. We are aware about that. When food get spoiled, that time it produces bad smell. We call this change a chemical change. Shall we call this is a chemical change? Right, we can call it as a chemical change, because when food will be prepared, that time their smell will be different, and when it gets spoiled, that time the chemical properties of that food material will be changes. That's why it is called as a chemical change. The smell and taste of that particular food material will be changed. That's why we can say that it is a chemical change. You must have noticed that a slice of an apple acquires a brown color if it is not consumed immediately. When we are going to eat an apple, and when we cut the apple and we are keeping that slice for half an hour or for 1 hour, after 1 hour we can saw that a brown color will be appear on that slice of apple. Why? Because of the chemical change. If you have not seen this change in color, cut a fresh of slice of apple and keep it away for some time. Suppose you not seen that, you take one apple, you cut a slice of the apple, and you keep that slice in an open surface. For half an hour, for 1 hour, for 2 hour, and afterwards you can see that the brown color will be appear on that particular slice of apple. Repeat the same activity with the slice of potato or brinjal. You can see this same type of brown color on the potato also, and slice of the potato also, and brinjal also. The change of color in these cases it due to the formation of new substance, is due to the formation of new substances. This change, why the color will be changes, because the new substance will be formed, and these are called as a chemical change. These are called as a chemical change. In chapter 5th we will learn afterwards this chapter. Now the next point is a protecting shield. A protective shield. Which protective shield will be there, we will see. You must have heard of the ozone layer in our atmosphere. We are aware about that. In our atmosphere ozone layer will be there, and it is most useful layer which is present in the atmosphere, because it protects us from the harmful ultraviolet radiation which comes from the sun. This ultraviolet, this ozone layer which protect us from the harmful ultraviolet radiation which comes from the sun. Ozone absorbs this radiation and break down to oxygen, which is useful for us, life gas which is useful for us, we are taking oxygen. Ozone, what happens when this harmful ultraviolet radiation will be removed, will be releases by the sun, and when it bombard on the ozone layer, ozone absorb this radiation and breaks down into the oxygen. Oxygen is different from the ozone. Oxygen and ozone both are different one. Both are different. They both are not same. Oxygen is different from ozone. Can we call breaking down of ozone a chemical change? Yes. When breakdown of ozone, it is called as a chemical change. Why? Because new substance oxygen will be formed. Already here mentioned, ozone absorb the radiation and breaks down into oxygen. In this same way, here new substance will be formed, oxygen. It absorbs ultraviolet rays and new substance will be formed, oxygen. That's why it is called as a chemical change. If ultraviolet radiation were not absorbed by ozone, it would reach the earth's surface and cause harm to us and other life forms. Ozone acts as a new natural shield against this radiation, and these ultraviolet radiation are absorbed by the ozone layer. And suppose ozone layer will not be there, what will be happen? These ultraviolet radiations will become on the earth's surface, and it cause harms to us also and other life forms also. And ozone act in this way, the ozone act as a natural shield against the radiation. And what will be happen? Suppose ultraviolet radiation will be comes on the earth, what will be happen? The rays cause aging and eye damage. Aging, कमी वयामध्ये वृद्ध होऊ शकतील लोक. Aging, eye damage, and can lower our body ability to fight off against illness. It can be lower, can be lower our body ability to fight off an illness, against illness. It also contribute to the skin cancer, and this ultraviolet radiation, it contributes to the skin cancer, leading to the skin cancer. That's why I already told that ozone is a most important layer which is present in the atmosphere, and in this way ozone acts as a natural shield against the radiation. Now here we already learned in chapter 1st that plant produce their food by the process of photosynthesis. And can we call the photosynthesis is a chemical change? Yes, we can say that the photosynthesis is a chemical change. Why? Plants, they are using what? Chlorophyll, water, nutrients and sunlight, and they are carbon dioxide, and they are preparing food material, and they are releasing carbon dioxide in the oxygen in the atmosphere. There are two new substances will be formed. That's why we can say that it is a chemical change. In which change new substance will be formed, that is called as a chemical change. Here two new substances will be formed, oxygen and food material, and that's why it is called as a chemical change, like starch, carbohydrates. That's why it is called as a chemical change. Now our next point, rusting of iron. Let us get back to the rusting. This is one of the change that affects on iron particles, and slowly destroy them. We are aware about that this rusting that affects on the iron particles which are lying in the open areas or which are lying where the humidity is more, that time it attacks on the iron particles and they destroy them. Since iron is used for making bridges, we are aware about that iron is the most useful material. Bridges, it is used for the making bridges, ships, cars, truck bodies and many other articles. The monetary loss due to rusting is huge. Monetary like economical, right? Economical. हे जे ब्रिजेससाठी, शिपसाठी, हे सगळ्यासाठी आपण आयर्न पार्टिकल्स यूज करतो, आयर्न मटेरियल यूज करतो. आणि ही जे रस्ट आहे त्याच्यामुळे कितीतरी वेळा त्या शिप्स किंवा कार्स यांचे जे पार्ट आहेत ते बदलावे लागतात, त्यामुळे आर्थिक लॉस हा मोठ्या प्रमाणात होतो. The process of rusting can be represented by the following equation. Can be represented by the following equation. First one, iron. Iron, when it comes in contact with oxygen which is present in the air and water, H2O, and it gets rusted, and the rust is a new substance and it is iron oxide, Fe2O3. Fe2O3, iron oxide. For rusting, the presence of both oxygen and water is essential. Both water or water vapor is essential. The rusting, when rusting will be happen, the presence of both oxygen which is present in the air when it comes with the contact with the air, and both are required. Only oxygen or only water is not required, both are required, oxygen also and water or water vapor. Instead of water vapor also, water vapor can be required for the rusting. In fact, if the content of moisture in air is high, which means if it is more humid, rusting becomes faster. Rusting becomes faster. In fact, suppose moisture is present in the air in a high quantity, that time what will be happen? Which means that it is a more humidity present in the atmosphere, or their areas, and that particular areas rusting becomes faster. That's why in a coastal areas humidity is more, and rusting process become faster in the coastal areas related with the hot areas. So how do we prevent rusting? Now we are aware about that iron get rusted, but how we can prevent the rusting? How we can prevent the iron particles from the rusting? Now you are aware about that in our classroom also iron benches will be there, and they are given after some days they are given by the color. Their painters, they are given the color for the iron particles. Why they are giving the color? Why they are giving the color for the iron particles? We will see in this point. So how do we prevent rusting? Prevent iron particles from coming contact with oxygen or water or both. We are aware about that for the rusting, the presence of oxygen and water or water vapor is required. What we have to do for prevent the iron particles? We have to stop their contact with oxygen, water or both. One simple way is to apply a coat of paint or grease. One simple way. What we have to do? We have to apply a coat of paint or grease on the iron particles. In fact, these coats should be applied regularly to prevent rusting. Another way is deposit a layer of metal like chromium or zinc on iron. Here two methods will be there how to avoid the rusting. First one, we have to apply a coat of paint or grease, or another way is deposit a layer of chromium or zinc. That materials will not be get rusted by these activities, like when they are contact with the oxygen and water. The process of depositing a layer of zinc on iron is called galvanization. The process of depositing a layer of zinc on iron is called galvanization. The iron pipes are used in our homes to carry water are galvanized to prevent rusting. The iron pipes which carry the water to our homes, that galvanized to prevent rusting. You know that the ships are made up of iron. The ships are made up of iron, and a part of them remains underwater, and a part of them remains under water. On the part above water also, water drops keep clinging to the ship outer surface, keep clinging to the ship's outer surface. Moreover, the water of the sea contains many salt. We are aware about that. We are getting salt from the sea water, and it contains more salt. The salt water makes the process of rusting formation faster, and this salt water is helpful for the rusting process, therefore the ships suffer a lot of damage. The ship suffers lot of damage from rusting in spite of being painted, and these ships, because of ship sea water, it contains more salt, and salt water, it is useful and it is helpful for the rusting process. That's why ships may be suffer from a lot of damage of a rusting, and for that purpose it will be being painted again and again, so much so that a fraction of ship's iron has to be replaced every year, and the materials which are come in contact with the water, that material will be replaced every year, of the ships replaced every year. And can you imagine the monetary loss to the world? Now from that we can imagine that what will be the monetary loss, what will be economical loss for the world because of the that rusting process. Here, stainless steel is made by mixing iron and carbon and metals like chromium, nickel, and manganese, and it does not rust. Now, our last point, crystallization. In class 6, you have learned salt can be obtained by the evaporation of seawater. We are aware about that salt we are getting from the seawater by the process of the evaporation. The salt obtained in this manner is not pure, and its crystals are small. When we are getting by the evaporation process salt, we are getting by the evaporation process from the seawater, but it is not in the pure form. Its crystals are so small. The shape of the crystals cannot be seen clearly. However, the large crystals of pure substance can be formed from their solutions, and the process is called crystallization. We can get the large crystals from the pure substance can be formed by their solutions, and this process is called crystallization, and it is an example of physical change. Because small particles will be there, and afterwards, after this process, we are getting big particles, only change in the shape or size. Now see the activity 6.9 we will perform in the laboratory. Here one question will be there. Use only dilute sulfuric acid. Be careful while boiling water. Why they are mentioned dilute? There are two types of solution, dilute sulfuric acid and concentrated sulfuric acid. Concentrated, it is harmful for us. For that purpose, here they mentioned we have to use dilute sulfuric acid. Now see the activity. Take a cupful of water in a beaker and add a few drops of dilute sulfuric acid. We have to take one beaker. In that we have to take a cupful of water, 1 cup water, and there dilute few drops of dilute sulfuric acid, and we have to boil the water. When it start boiling, add copper sulfate powder while stirring continuously. We have to add copper sulfate powder slowly, and we have to stir it continuously. त्याला मिक्स करत राहायचं, continuously stir करत राहायचं. Continue adding of copper sulfate powder till no more powder can be dissolved. Up to which time we have to add? Up to this time where the copper no more powder can be dissolved in that solution, and filter the solution. Afterwards, when powder will not be dissolved in that particular solution, after that we have to filter the solution, allow it to cool. Afterwards, we have to put that particular beaker for a while, and afterwards when it cool, and that time we do not disturb the solution, and do not disturb the solution when it is cooling, and look at the solution after some time. And can you see, when we see that there the crystals of copper sulfate will be formed. the crystals of copper sulfates will be formed. Suppose it is not formed, we have to wait for some time, we have to wait for more time. Here you can see in this picture, figure 6.6, here when crystals, when water will be there, then afterwards when we are adding dilute sulfuric acid, afterwards copper sulfate powder, when we are added, that time it shows in a first in a beaker, afterwards here in a round shape there shows the crystals which are obtained by this process. Now in this chapter we learn about the physical change and chemical change. We have, what you have to learn from this chapter, we have to identify in our daily life which many we have to identify the changes around you, that you have to bifurcate in a physical change and chemical change. You prepare homework for you, you prepare one chart, there you write the changes and bifurcate them in a physical change and or chemical change, or you write physical changes, 10 example of physical changes and 10 example of chemical changes. Today our this chapter will be completed.